Good morning, Year 4. I hope you're well. Welcome to today's maths lesson. Today you are going to be subtracting fractions. But to start with, you have your daily fluency. Can you please spend between 3 and 4 minutes on these questions, please? Pause the video and write your answers down on your piece of paper underneath the date and title for today. Off you go. Okay, question number 1. Find the difference between 12 sevenths and 6 sevenths. Well, we know when we are finding the difference, we are looking at what number you add to maybe 6 sevenths to get 12 sevenths, and the missing number is 6 sevenths. Complete the sequence. Well, we can see it's going up. The fractions are going up in 7 100ths each time. So 21 100ths add 7 100ths would be 28 100ths. And 28 100ths add 7 100ths would be 35 100ths. Find the area of each colour in the shape in squares. We can count the orange squares and see that there are 5 squares. And we can count the blue squares and see that there are 7 squares. Finally then, write 83 in Roman numerals. Well, the answer is LXXXIII. Do you remember what L is in Roman numerals? That's right, it's 50. And what is X? That's right, 10. So we have 50, 60, 70, 80, and what's I? 1. So 81, 82, 83. So a very large number in Roman numerals, but I hope you remembered how to do that one. You do have some more learning questions for you just to help you with today's task and your learning for today. So can you pause the video, have a go at the following 4 questions, please. Write your answers down again. This should not take you longer than 3 minutes, okay? Off you go. Okay, how did you do? 5 subtract 3 is 2. In the same way that 5,000 subtract 3,000 gives us 2,000s. What is the difference between 9 and 3? Well, to get to 9 from 3, you need to add 6, so the difference is 6. When adding fractions, add the something and keep the something the same. We know that the denominator is kept the same and we add the numerators. And then we're looking at equivalent fractions. So we know, what did we divide 9 by to get to 3? How many 3's are in 9? 3, 6, 9. We divided it by 3. So that means we need to divide 3 by 3 to get our numerator. How many 3's are in 3? 1. So 3/9 is equivalent to 1/3. We could do the same here and look at 6/10 is equivalent to what? Well, we know that each of these numbers can be divided by 2. What's 10 divided by 2? 5. And what's 6 divided by 2? 3. So we could have 3/5. Super job, Year 4. Wells and if you've got all of those right. Now, yesterday we were looking at adding numbers, 2 or more numbers. Today we are going to look at subtracting. So I have this calculation here, 5 sevenths take away 3 sevenths. And I think I can use my bar model to help me. How many parts is my bar model going to be split into, Year 4? That's right, it's going to be split into 7 parts because that is my denominator for both fractions. My biggest number, my biggest fraction is 5 sevenths, and I'm going to show that on my bar here. I can see that I am reducing this number by 3. I am subtracting 3. So what I can do is I can cross out 1, 2, 3 of my parts. How many parts am I left with that are shaded in my bar model? That's right, I'm left with 2 sevenths. So 5 sevenths take away 3 sevenths gives us 2 sevenths. Now this process is known as reduction. So when we are reducing a number, we are making it smaller because we are removing something or taking it away. And in this circumstance, we are taking away some of the boxes. We are taking away some of the fractions to get 2 sevenths. What I would like you to do is use the same method of reduction to work out the answer to this question, please. Pause the video and off you go. Okay, did you recognise that this time our bar is being split into 9 parts and our largest number is 8 and we are reducing that by 5. And we can see that we have got 3/9 left over. So 8/9 subtract 5/9 gives us 3/9. Now another method we could use to work this out is a part-whole model, because we can put our 8/9 in the top circle, and we already had one part, which was 5/9. And we know that 5/9 add 3/9 equals 8/9. So 8/9 subtract 5/9 must be 3/9 too. So when we are partitioning, we are splitting the whole into two or more parts. I want you to think if you can make this fraction smaller by thinking of any equivalent fractions that 3/9 has. Can you think if you can make this fraction 3/9 smaller? Does it have an equivalent fraction? Pause the video and have a think. Did you remember that when we find equivalent fractions, we have to either divide or multiply the number by the same for either the numerator and the denominator? So here we can see that 6/8 is equivalent to 3/4, because dividing them both by 2 gives us 3/4. Now, if we think of the numbers 3 and 9, what number divides into them both? Can we divide 3 by 2? No, we can't, can we? Can we divide 3 by 3? Yes, we can. 3 divided by 3 is 1, and 9 divided by 3 is 3. So 3/9 is equivalent to 1/3. Well done if you got that one. Can you have a go at questions 1 to 5 on the worksheet, please? Pause the video and have a go. How did you get on? Did you find that easy? I bet you did. I think you're going to be superstars at this. We've got some more questions here, and I'm going to show you a slightly different method. This is to do with finding the difference. So we've got 9/10 subtract 3/10. Now, we can see that our denominator is 10. So we're going to split it into 10 parts. We're also going to find 9/10, and I have shown that using my orange pen here. And I know I'm subtracting 3/10. But when we're finding the difference, we can use another bar model to help us. So I can see on my first model, I can see 9/10, and on my second model, I can see 3/10. Now what I need to do is I need to find the difference between 9/10 and 3/10. So I'm just going to mark where 9/10 is and where 3/10 is. And then I can count the boxes in between. And I can see that in between these two numbers, there are 6/10. Now we have just found the difference. We have made a comparison between two sets of numbers. We have looked at how much more there are in 9 than 3. We've also thought about how much less there are in 3 than 9. We've also been able to make an equivalent fraction here. Both of these numbers can be divided by 2. What is 10 divided by 2, year 4? 5, well done. And what is 6 divided by 2? 3. So we've made the fraction 3/5. Fantastic. What I would like you to do is try and find the missing number. Can you pause the video, find the missing number to this question, please? Off you go. Okay, how did you get on? Let's have a look at the different methods that we could use. We could use the reduction method here. My bar model has been split into 11 parts, and I've shown 7 of those parts. If I want to find my missing number, I can mark where 2/11 will be. And then I can start crossing off how many I have had to cross off to get to 2/11. How many have I crossed off? That's right, 5/11. I could also use another method to help me too. I could use the part-whole model here. I can see that I started with 7/11. I have partitioned my number into 2/11, and then my remaining is 5/11 in the yellow here. But what I can also do is I can use finding the difference to help me too. I started off with 7/11. I've got my 2/11 here. I can put a marker where 2/11 is and 7/11 and find the difference, which will be 5/11. Super. One more question for you here, and then we will have a go at the reasoning and problem solving questions. So this has to be balanced so that this side, the addition, is the same as the subtraction. Can you work out what numerator should go here, please? Pause the video and have a think. Okay, if we start by looking at our bar models here, we can see that 2 elevenths add 5 elevenths gives us 7 elevenths. So we know that this side has to be 7 elevenths too because they are equal. But what take away 3 gives us 7 elevenths? Well, we can see that 7 elevenths is shown here. But to find out what our numbers started with, we can do the inverse. What's the inverse of subtraction? That's right, addition. So we can add our 3 on, and now we have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We started with 10 elevenths because 10 elevenths take away 3 elevenths gives us 7 elevenths, and 2 elevenths add 5 elevenths also gives us 7 elevenths. Can you please have a go at the rest of the questions on the worksheet? Off you go. Pause the video. Okay, the final part of today's lesson then, some problem solving and reasoning questions. So Lisa has 9 elevenths of a chocolate cake. She gives Talia 6 elevenths of the cake. How many elevenths does she have left? What would my number sentence be with my fractions? Pause the video and have a think. Would it be 7 elevenths take away 9 elevenths? No, it wouldn't, would it? It would be 9 elevenths take away 6 elevenths. What is 9 elevenths take away 6 elevenths? That's right, it's 3 elevenths. So Lisa would have 3 elevenths of chocolate cake left, which is more than enough for me. Another question here, is Seren correct? She says, I subtract 4 elevenths from 4 twelfths from 11 twelfths. Jack has 7 twelfths. I now have more than Jack. Is she correct? Well, what is 11 twelfths subtract 4 twelfths? Pause the video and have a think. 11 twelfths subtract 4 twelfths is 7 twelfths. Jack also has 7 twelfths, so does Seren have more than Jack? No, Seren does not have more than Jack. Why does she not though? Because we need to explain our brain. Why does Seren not have more than Jack? Oh, that's right, because she has 7 twelfths too. They are both the same. They both have 7 twelfths. Well done. Final question then. Choose fractions to make the part-whole model correct. So I can see that I have got one part is 7/9. I need another part to make my whole, but I can only use these fractions. Let's start by eliminating the ones that we cannot use. What is 7/9 add 6/9? Well, 7 add 6 is 13. But do we have 13/9 available? No, we don't, do we? So we cannot use 6/9. Let's try 8/9. What is 7/9 add 8/9? Well, 15/9. Do we have that there? No, we don't, do we? We can rule 8/9 out. We've already tried 6/9 once too. Let's try 1/9. What's 7/9 add 1/9? 8/9. Do we have 8/9 there? We do. So we can use 7/9 add 1/9, giving us 8/9. Super job, well done. Like yesterday, you're going to either choose your blue problem solving and reasoning questions to answer or your orange reasoning and problem solving questions to answer. Orange is a bit trickier than the blue, so depending on how confident you feel, I think lots of us can try the orange ones today. Remember that when you need to explain yourself, like for these questions here, you might want to use a different piece of paper just so you have more room. Really excited to see your lovely problem solving questions today, Year 4. Have a fantastic rest of your day. Bye!